As you can see, we're talking about trigonometry today. Lesson 1, and we're going to look at stage 5.1 and 5.3. So it might seem a little bit strange that there's no 5.2, but that's the way lesson 1 works out. So first of all, level 1, so this is 5.1. So I'm thinking all students in stage 5 should be able to do this. And I'm calling it level 1. The learning intention is to use the sine, cosine, and tangent ratios for a given angle in right-angled triangles. And this is what I would like you to be able to do. So identify the hypotenuse, adjacent sides, opposite sides, with respect to a given angle in a right-angled triangle. So we are talking about right-angled triangles today. So we're labeling the side lengths. And then we're going to talk about these ratios and use trigonometric notation. So first of all, we are talking about right-angled triangles. So you'll see this symbol here is used to represent a right angle. The hypotenuse, which I've got in green, is the side opposite the right angle. So think about the right angle, and it's the side opposite that right angle. And the name that we give to that is the hypotenuse. You might like to research why it's called that. I'm not going to talk about it in this video. So once we've found the hypotenuse, we can find the opposite side. And this time around, we're talking about the side opposite the given angle. So you can see here that we're actually talking about angle C for this triangle. So the trigonometric ratios apply to this angle. The hypotenuse is opposite the right angle, so that doesn't matter if the angle's here or up here for the hypotenuse. But for angle C, we're looking at the side opposite, which is the blue one. And the last side that I like to find is the adjacent side. Again, we're using angle C as our reference. So it's the one next to, in between that angle C and the right angle. So it's adjacent to both. Adjacent means next to. And you can see in this diagram, everything's just been flipped around. So the hypotenuse is opposite the right angle, opposite the angle that we use as our reference point, and the adjacent is next to the angle and next to the right angle. So when we talk about the ratios, trigonometric ratios, we have sine, notice the E there. We have cosine, complementary sine, and we have tangent. So the sine ratio is the opposite over hypotenuse. So the side opposite angle C and the hypotenuse. You'll notice that we do use abbreviations. So we say sine C equals opposite over hypotenuse. For cosine, we have adjacent, so this one, over hypotenuse. The abbreviation is cos C over adjacent. Cos C equals adjacent over hypotenuse. And the last one, the tangent ratio, is tan C equals opposite over adjacent. So for example 1, which should go in your notes book, we need to find all 3 trig ratios. It should be ratios. Sine C, so we're still looking at this angle, is the opposite number, which is 3, over the hypotenuse. So we get 3 over 5. And you'll notice here we've got the abbreviations for all 3 as well. Cosine C is the adjacent, the one next to it, over hypotenuse. So that's 4 over 5. And tan C is the opposite over adjacent. So opposite over adjacent, so we get 3 over 4. So now there's a question for you to do, to find all 3 trig ratios in the triangle below. So pause the video, do this question in your workbook, and then check to make sure you got it right. So we can use SOHCAHTOA to help us remember the trig ratios. The sine is opposite over hypotenuse. We're still using this angle here. So we've got opposite, which is 6 over 10. So 6 over 10, and you'll notice that we can simplify that to 3 over 5. Cos C, so SOHCAH, the car bit is adjacent over hypotenuse. So adjacent over hypotenuse, so 8 over 10. Make sure you simplify the fraction. Tan C is the opposite, 6 over adjacent, so 6 over 8, and we simplify the fraction to 3 over 4. Question 2, we have find the 3 trig ratios again. You'll notice that we have 2 and 3, and this time it's a decimal. So we can actually find this value using Pythagoras' theorem. 2 squared plus 3 squared equals this number squared. So we do get decimals or exact numbers or surds, which we'll talk about later. SOHCAHTOA again. Sine first. I like to do sine first. So the angle's up here this time. So we have opposite over hypotenuse. Remember, hypotenuse is opposite the right angle. So for cos, we have adjacent. So 2 over hypotenuse, 2 over 3.61. And for tan, we have opposite over adjacent. So when you're setting these out, I like to find the hypotenuse first, the opposite side, the adjacent side. I like to write it out like that, and then do the ratios. So for level 3 now, so we expect some students to be able to do 5.3 work. Not everybody. The learning intention is to solve trigonometric equations, and students should be able to Determine and use the exact sine, cosine, and tan ratios for 30, 45, and 60-degree angles. Today I'm just going to show you the basics, and then we'll have equations. So find the value of sine 45, cos 45, and tan 45. If we have 45 degrees in a right angle triangle, this angle up here will be 45 degrees as well, because these three add up to 180. So we actually get an isosceles triangle. So the opposite and adjacent are both 1, and the hypotenuse is the square root of 2. And this is what we call a surd, or an exact value. So when we do sine 45, we get opposite over hypotenuse, so 1 over square root 2, which you can see here. Cos 45 is 1 over square root of 2 as well. And tan 45 equals 1 over 1. So these are exact values, or surds. So notice that for 45 we use an isosceles triangle. For the next one, when we use 60 degrees, we have an equilateral triangle. So this triangle here, the orange one, is an equilateral triangle. So we get 60 degrees, 60 degrees, and 60 degrees. If we draw a perpendicular line to the base down here, this bisects the angle here and here. So we get 90 degrees and we get 30 degrees. So for sine 60, we have opposite over hypotenuse. So for sine 60, we get the square root of 3 over 2. For cos 60, we get 1 over 2. And for tan 60, we get the square root of 3 over 1, which we just write as square root of 3. So for example 4, sine 30, we're still using the same triangle from before, but we're referencing the 30 degrees up here. So this time around, the hypotenuse is still 2, so I like to draw a H there. The adjacent is the square root of 3, and the opposite is 1. So remember, this is our reference point, this angle here. So opposite is down here, adjacent is next to, and hypotenuse is opposite the right angle. So for sine 30, we have 1 over 2. For cos 30, we have root 3 over 2. And for tan 30, we have 1 over root 3. And that's it for today's lesson. Let me know if you get